Welcome to the Professional Data Engineer Crash Exam course. Today we will focus on PubSub, an event-driven asynchronous messaging service designed to securely decouple the senders from the receivers. This module illustrates the complete message flow, starting from various publishers producing events, moving through the globally distributed and highly scalable PubSub engine, and finally routing the data to multiple types of subscribers for processing and consumption. Decoupling is a fundamental aspect of this architecture, acting as a structural barrier between senders, producers, and receivers processing. The PubSub core is serverless and scales globally, ensuring high availability with global routing and an SLA of 99.995%. The architecture classification framework highlights use cases across data pipelines, microservices, and system reliability. Key areas include real-time ingestion, decoupled execution, broadcasting updates, and optimizing resources for high availability. The core components are the publisher, which produces events, the topic and schema, serving as the routing hub, the message and attributes, which include the payload and key value attributes, and the subscriber and subscription for processing events. The flow begins with the publisher creating a topic. Messages are persisted until delivered and acknowledged. PubSub forwards them via push or pull to the subscriber, which receives and acknowledges the message before it is removed from the queue. The pull model is ideal for large volumes and maximum efficiency, requiring an explicit ACK. The push model offers lower latency and is best for simpler dependencies, with an HTTP 200 acting as the ACK. Fanout allows a single publisher to send messages to one topic, which is then distributed to multiple subscriptions. This enables different backend systems to process the exact same data. The default delivery guarantee is at least once, where duplicates and out-of-order delivery are expected. Exactly once is available for pull subscriptions, but requires additional application-level logic and is limited to a single region. Throughput optimization is achieved through batching, which combines publish requests to reduce costs. The trade-off is a slight latency. Backpressure occurs if the publish rate exceeds the batching capacity. Engineering best practices include using a dead letter queue for failed messages, exponential backoff for retries to establish flow control, and setting ACK deadlines to prevent duplicate deliveries. Proper provisioning and alerting are also crucial. For migrating from Kafka to Cloud PubSub, a phased approach uses a sync connector to copy messages. Subscribers are then individually updated. Key features include seeking to a specific offset and retaining per key ordering. Comparing Kafka and Google Cloud PubSub, Kafka offers durable persistence and consumer-managed offsets. PubSub is ephemeral, service-managed, and fully serverless. Both offer at least once delivery, with different ordering guarantees. The PubSub monitoring dashboard tracks key metrics. Publisher-side metrics detect traffic spikes and latency. Subscriber-side metrics track backlog and identify inefficient pull configurations. Billing is driven by data throughput, storage duration, and network egress. This complete event-driven architecture blueprint illustrates a secure, loosely coupled, and globally scalable system. It includes batching, various routing options, load balancing for subscribers, and a dead letter queue for dropped packets.